In section 1.3, we're going to look at 6 basic functions. The first function is referred to here as a identity function. You may know it as a line. And the line that we're going to look at is going to cross through the origin right here, and then it's going to go up 1 over 1 in a positive direction and cross through all of these hash marks. Then down here, down 1 to the left 1, that makes a positive motion because we're going from left to right, we're going up and to the right. And we end up with all of these points. See if I can connect them. There we go. And that is our identity function, or the line y equals x. Now the properties of this function are fairly straightforward. The domain is from negative infinity to infinity. The range is from negative infinity to infinity. And what that means is that the x values, all of the x values are covered on this line. And the range, the y values, all the y values are covered on this line. The function increases from left to right its entire domain, and it does not decrease. Now, on the y-intercept, it goes through the origin, so the y-intercept happens at 0, 0, which means that the x-intercept is also at 0, 0, right there at that origin. It does not have a local min or a local max because there's nowhere on this graph that it turns around and goes the other direction, up or down. It continuously goes up and to the right. So there's not a local min, there's not a local max, and the interval of continuity is from negative infinity to infinity. And that's our first basic graph. Our second basic graph is called the squaring function, also known as a quadratic. And you know it probably as y equals x squared. This graph looks like this. It starts at the origin, and then for every x value, you square it. So 0 squared is 0, 1 squared is 1. Oh, I gotta check my scale, sorry. Let me erase that. If you check your scale, which I did not, always check your scale. 1 is located right here on the x-axis, and 1 is located right here on the y-axis. So if I go to x equals 1, 1 squared is 1. If I go to x equals 2, 2 squared is 4, which is up here. And if you remember, we use this as our example of an even function. So let's move to the negative values, and you'll see that symmetry with the y-axis. When x equals negative 1 squared is 1. When x equals negative 2 squared is 4. So we end up with this parabolic shape, roughly drawn like this. Okay. Function. It clearly has a local min. The local min occurs down here where it's turning, where it goes from decreasing to increasing. So the local min is at 0, 0. It does not have a local max. This function is continuous for all values. So its interval of continuity is from negative infinity to infinity. Going over here to the first column, the domain is all real numbers. Because all of the x values are covered, you can plug in any x value that you want. The range, however, has a starting point at 0, and then it goes up indefinitely. The function has an x-intercept at the origin, so 0, 0, and the y-intercept's at 0, 0. The function decreases. Remember, decreasing and increasing comes from left to right. So the function decreases from negative infinity down to 0. And then it starts increasing, starts moving up and to the right from 0 to infinity. Our next basic function is a cubing function. You probably have seen it before. F of x equals x cubed, but also as y equals x cubed. That means that for every x value, the y value ends up being the cube of that. So starting at 0, 0 cubed is 0. 1 cubed is 1. And then 2 cubed is 8, which is way up there. I'm just going to put a dot up there, but it's a little bit further than that. Y equals x cubed is an odd function. So that means it's symmetrical with respect to the origin. And that means that this point of 1, 1 could be traced back through the origin to the point -1, -1. Or you could simply say -1 cubed is -1. -2 cubed is way down here. -2 cubed is -8, way down there. And we end up with a graph that looks somewhat like this. Okay, and it's symmetrical with respect to the origin. It's an odd function. To fill in all of this information, we have a domain. It has all of the x values. The range, it has all of the y values. The function is continually increasing from left to right. So it increases across all values. The x-intercept is at the origin, so 0, 0. The y-intercept is at the origin. It does not decrease. It does not have a local min or a local max. And it's continuous from -infinity to infinity. Our fourth basic function is the square root function. Y equals the square root of x. Notice that this is only the positive square root of x, which means that as we look at this, you can put in only positive values, or excuse me, non-negative values for x. Our next basic function is the square root function, which you probably have graphed y equals the square root of x many times. And if you remember, since we have a square root here, the input value, or x, must be non-negative, meaning that x has to be greater than or equal to 0. And in this case, since we have x is greater than or equal to 0 for this basic function, when I plug in my x values, I end up with y is greater than or equal to 0. And just looking at it algebraically gives us our domain, 0 to infinity, and our range. Now, if you wanted to graph this function on your calculator, you certainly could. You would hit y equals, and then the square root is down here above the x squared. So you'd hit second x squared, and the square root pops in. Hit your variable button, x, and graph. There it is. Now, if we take a look at its table, hit the trace button, or hit, if you want to do that, or second graph to pull up the table. You'll notice everywhere x is negative, you get an error. And then down here, we have all of the values for the range and the domain that the calculator is showing us as we increase the x value by 1. Notice there's quite a few decimals there, and that has to do with the fact that it's a square root. So the square root of 2, x equals 2, is irrational, and the square root of 2 is approximately 1.414. Square root of 3 is irrational, 1.7321. Square root of 4 gives us a nice pretty integer of 2. So let's take a look at these values, or perhaps the graph, whichever one you're most comfortable with. I'm going to use a table, and fill in this as best as we can with the scale that we've been given. So to start off with, the square root of 0 is 0. The square root of 1 is 1. Check your scale. And then the square root of 2 and 3 are very not nice numbers. As I said, they're irrational. So let's go to 4 and see if we can manage to plot it. I believe 4 is roughly right here on this scale. So the square root of 4 is equal to 2 in our y value, and we end up with this graph, which matches our graph on our screen. Now, to figure out the rest of its properties, notice the function is continually increasing, so it's increasing from 0 to infinity. It does not decrease. The x and y intercept are at the origin. It doesn't really have a local min. You could say that this is the lowest point it can get and it increases to the right. So I'm going to say I'm going to write down a local min. When I said it didn't really have a local min, what I meant was it doesn't fit our definition of where we decrease and then we increase. With this particular function, because it has a clear starting point on the domain, where it starts in this case is its lowest point. So I'm going to say its local min is where it starts at. That's as low as we can go and make this function work. The local max does not exist because it continues to increase. And as it increases, it is continuous. So its interval of continuity is from 0 to infinity. All right, let's take a look at something close to the square root, the cube root function. Now, the cube root function is found under our math button on our calculator. So let's hit y equals. Let me clear this out. And we're going to go to the math button. And you notice the cube root, it looks a little funny on the menu, but there it is, number 4. That's our cube root. So cursor down to 4 or hit number 4 and enter. And our cube root, it matches that little 3 right up there, pops into our y equals editor. Now we're just doing the cube root of x, so let's graph it and see what it looks like. Looks like an elongated S. That is because we are taking the cube root of all of our numbers. I'm going to take just a moment and do a table here for you so we can get an idea of what's happening, and then we'll look at the table on our graph. This is our x and this is our y. Cube roots can be negative. Notice it's graphing over here in the negative. So let's start with all of our cube roots that we know. And you may be saying, what cube roots are those? Depending on your knowledge, you may know your cube roots off the top of your head. That 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. And likewise, the negative ones are -1 cubed is -1, -2 cubed is -8, -3 cubed is -27. To show that on our calculator, just very quickly, 1 to the third, 1 cubed is 1, -1 cubed is -1. And that -1 cubed is -1 because it's -1 times -1 times -1. Notice the parentheses I have to put around my negative values, so that negative number, let's do -4, so that negative is included in our number. So -4 cubed is -64. To fill this in, we're doing a cube root. So we're going to do the cube root of -8, the cube root of -1, cube root of 0, 1, and 8. And once again, the reason I chose those numbers is because I can get the cube root of -8 very quickly. The cube root of -8 is equal to -2. And if you wanted to see that on your calculator, you would hit, go back to our home screen, get out of the graphing, and we would hit Math, number 4, and I would type in -8 and hit Enter. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So I'm going to graph what I can on this scale that I have over here. So I know that it goes through 0, 0. I know at +1, y is at +1. 2 and 3, if we go to our table, second graph, 2, 3, 4, 5, 6, 7, those are all irrational numbers. They're very difficult to graph. So I'm just going to stick with the whole ones, and I'm going to say that over here, way over here at 8, we finally get up to 2. Right, so on the left-hand side of the origin, we have -1. That matches with the graphing point of -1. And once again, way over here at -8, we finally get to -2. So, let's see, like that. So there's our graph on our page. And if you are comfortable graphing with fractions, you certainly could have estimated those fractional values on the y. But this is close enough, and it matches my graph pretty well. So let's fill in this information. You can plug in any x value that you want, and the range will eventually work out to be all real numbers as well. You're just going to have some very large x values to get there. As we move from left to right, the function increases across its entire domain, which means it does not decrease at all. The x-intercept's at the origin, the y-intercept's at the origin. It does not have a local min, it does not have a local max, and it's continuous across all values of x. Our last function to graph is the absolute value function. So this basic function can also be graphed on your calculator, but to get to the absolute value symbol on your calculator, you have to go through the calculator menu of catalog. Let me show you how it works. I'm going to go to my y equals, and then I'm going to find my catalog. Down here on all of the TI graphing calculators, right above the 0, there should be a catalog written out there. To get to that, hit second, and then 0, and absolute is the first one that pulls up. So just hit enter, and there's our absolute value bars. So we're going to graph the absolute value of x, and it's this nice V shape. I will say there are other ways to get to the absolute value on your calculator, but that is one of the quickest ways to do it. Looking at the graph and the characteristics of it, it has the equation y equals x to the right. So it's graphing up and over 1 to the right. Then it has the equation y equals negative x the left. So to the left 1 and up 1, to the left 1 and up 1 will give us that negative branch. The domain is all real numbers, because you can put any number you want into that function. The range is clearly set. Let me grab my eraser for a moment. The range, the y values moving up the y-axis. The range starts at 0, goes to infinity. It increases to the right of the origin, so 0 to infinity, and it decreases to the left of the origin, so negative infinity to 0. And once again, when I say decreasing, I'm saying coming in from the left-hand side, the function is going down. X-intercepts at the origin, Y-intercepts at the origin. It does have a local min right there, and it fits our definition or our description of a local min very nicely. It does not have a local max, and it's continuous across everything. Going over these basic functions is very important, and memorizing their shapes, knowing what they generally look like, is also very important, because we're going to use these basic functions throughout the course, and we're going to study some of them very closely. And our next particular section is going to be about moving these functions across the plane. So while we're working with those problems, if you knew what the basic shape of the graph happened to be, and you knew about where the points were that the graph crossed through, then the next section would be much easier. So be sure to study these graphs and study their properties, because it will make this course easier as we go forward.